All right, guys. Now let us talk about the velocity of a satellite in an orbit. Okay. Yes. So satellite, satellites. We have natural satellites like our moon. We also have artificial satellites. Okay. You know them. Yes. So mm, now let's talk about them. Their velocity. Okay. Remember, I told you that for them to keep moving around the earth, they must have a velocity. Do you understand? They must have a velocity. If they do not have a significant velocity that will allow that to happen, they will fall inside the earth. Do you understand? So remember that it is the earth's gravity, the earth's gravitational force, that is what keeping them moving along that what elliptical path or circular path. It is the earth's gravitational force. So let us concentrate on that. Now, remember that, like I said, the Earth's gravitational force provides the what? The centripetal force. So this is the force of attraction, F equals to Gmm all over what? R squared. This is the force of attraction. So now, this is the Earth. This is the planet Earth. This is the orbit of a satellite. This is the orbit of a satellite. Let's say this is satellite X. So now, like I said, I told you, the gravitational force of the Earth provides the what? The centripetal force on the satellite. So that means that, remember, from circular motion, the centripetal force is equals to F is equals to mv squared over r. This is the centripetal force of a satellite. So now we equate these two forces, like we equate them. So we now have Gmm over r squared is equal to what? mv squared over r. So when we cancel the small letter m, we now have Gm. Remember, as you are canceling this one, we will cancel the one r, will cancel another r. So we now have Gm over r is equal to what? V squared. So Gm over r is equal to V squared. Therefore, V is equal to what? Square root of Gm over what? Over r. Now remember that G is equals to Gm over r squared. That is Gm is equal to gr squared. Gm is equal to gr squared. So now we have that. We can also have that V is equal to square root of gr squared over r. So this one r will cancel. So therefore V is equal to what? Root gr. So this is the equation for the velocity of the satellite along this orbit. Either you use this one, or you use this one. Okay? So this is it. So now they must be at this velocity for them to be able to do what? To move around the earth. Do you understand? They are falling, do you understand? But they have this linear velocity. Do you understand? According to Newton's first law, if there is no gravitational attraction, they will continue to move along a straight line forever. Do you understand? Their inertia we keep them in that state. But because of that is in that state of motion, but because of the Earth's gravity, it's attracting them. So it forms what? A circular orbit. Let me emphasize more on this. See, there is a particular speed a satellite will be. It will form a circular orbit. If that speed is reduced, the orbit will be elliptical. Do you understand? Yes, the orbit will be elliptical. Instead of being circular, it will be elliptical. So take note of that. Yes. So now Another thing I will add to this thing is, remember that I said earlier that our planet is a rotating planet. It's rotating. So, so now the gravitational acceleration minus the free fall acceleration is equal to what? V squared over R. Do you understand? So now, this is the gravitational acceleration. That's the acceleration that the Earth is providing. Acceleration due to gravity. This is the free fall acceleration. The acceleration of an object, that is, if you keep the object on Earth, the acceleration that it will have. Do you understand? When placed on Earth. Do you understand? This is the acceleration we use to calculate the weight of objects on Earth. But for most practical purposes, we can equate the two. That is, gravitational acceleration is equal to free fall acceleration. Yes. Because the difference is small. So, with this equation, you now understand that because of the fact that our planet is rotating, part of its gravitational acceleration or gravitational force is being used in as a centripetal force. Do you understand? Of like, as you are standing on Earth now, you have a centripetal force on you because the planet is what? Rotating. Now, look at your weight. If you want to calculate your weight now, that is, you make this subject of the formula. So we now have GA minus V squared over R, then which is equal to what? G. So this is the free fall acceleration. So G is equal to GA minus what? Centripetal acceleration. Let me just put it AC. Do you understand? So this is it. So just imagine that if our planet is rotating very, very fast, such that AC is equal to what? Is equals to GA. Say, for instance, if this thing happens, G will be equals to GA minus GA. So G will be equals to 0. You know what it means? You will have no weight at all. That's, you will be weightless on this planet. You will feel no weight. Do you understand? So that would be all.